GPT-4 and the evolution of cognitive architecture for advanced NPCs. The development of artificial intelligence has seen remarkable advancements in recent years, with models like GPT-4 pushing the boundaries of what's possible in natural language processing and generation. Concurrently, the video game industry has been striving to create more immersive and realistic experiences, with a particular focus on enhancing the capabilities of non-player characters, NPCs. The recent revelations about GPT-4's architecture, specifically its mixture of experts paradigm, have introduced new perspectives on cognitive architectures that may have significant implications for the development of advanced NPCs. This paper explores the potential synergies between GPT-4's design and the ideal cognitive architecture for NPCs, examining how insights from general AI models can inform and enhance game-specific AI development. While GPT-4's architecture offers valuable insights for NPC cognitive design, it's crucial to recognize that game-specific innovations remain essential for creating truly engaging and believable virtual characters. At the core of GPT-4's design is the mixture of experts model, a sophisticated approach to AI that involves multiple specialized submodels or experts, each trained to handle specific types of tasks or information. This architecture allows for efficient task-based division and dynamic allocation of computational resources. In practice, when GPT-4 receives an input, a routing mechanism determines which expert or combination of experts is best suited to process that particular input. This approach enables the model to handle a wide array of tasks with remarkable efficiency and versatility, as it can leverage specialized knowledge and processing capabilities as needed. The advantages of this architecture lie in its ability to process complex, multifaceted inputs by breaking them down into manageable components. This division of labor allows for more nuanced and context-appropriate responses, while also optimizing computational resources. In the realm of video games, developers have long been working towards creating more sophisticated NPCs. Current approaches often involve modular designs that separate different aspects of cognition, such as emotion processing, memory management, decision-making, and sensory input analysis. These modular architectures aim to create NPCs that can react believably to player actions, remember past interactions, make contextually appropriate decisions, and process their virtual environment in a way that mimics human cognition. However, creating truly adaptive and believable NPCs remains a significant challenge. Existing approaches often struggle with real-time learning and adaptation, maintaining consistent long-term behaviors while allowing for character growth, and balancing computational efficiency with the need for complex decision-making processes. These limitations can result in NPCs that feel static or predictable, detracting from the player's immersion in the game world. The mixture of experts model employed by GPT-4 shares some interesting parallels with the modular design of advanced NPC architectures. Both approaches emphasize the importance of specialized processing for different types of information or tasks. This similarity suggests that some principles from GPT-4's design could potentially be adapted to enhance NPC cognitive architectures. For instance, the dynamic task allocation seen in GPT-4 could inspire more efficient decision-making processes in NPCs. By routing different types of inputs, for example, player actions, environmental changes, narrative events, to specialized processing modules, NPCs could potentially respond more appropriately and efficiently to complex game scenarios. Moreover, the adaptability demonstrated by GPT-4's routing mechanism could inform the development of NPCs that can better adjust their behavior based on the current game context or player interaction patterns. This could lead to more dynamic and engaging NPC behaviors that evolve throughout the course of the game. Despite these parallels, there are significant divergences between GPT-4's capabilities and the requirements of advanced NPCs. One key area of difference is emotion simulation. While GPT-4 can generate text that appears emotionally appropriate, it lacks the deep emotional context and evolved responses required for truly believable NPCs. In gaming, emotions need to be more than just appropriate responses, they should form a consistent narrative that guides NPC behavior over time. Another crucial divergence lies in memory processing. GPT-4, despite its vast knowledge base, doesn't have a dynamic memory of past interactions in the way that advanced NPCs require. NPCs need to be able to recall past events, evolve based on these memories, and use them to inform future interactions, creating unique experiences for each player. Furthermore, the real-time learning and adaptation required in gaming environments present challenges that are not directly addressed by GPT-4's architecture. While GPT-4 demonstrates a form of adaptability through its dynamic routing, it doesn't learn or evolve its knowledge base in real time, a capability that would be invaluable for creating truly responsive NPCs. Despite these limitations, the insights gained from GPT-4's architecture can inspire innovations in NPC cognitive design. The concept of efficient routing mechanisms could be adapted to create NPCs that can quickly switch between different behavioral modes or decision-making strategies based on the current game context. Developers could explore the creation of specialized modules for emotion processing and memory management, inspired by the expert models in GPT-4 but tailored specifically for the needs of game NPCs. These modules could work in concert with more traditional game AI techniques to create NPCs that are both computationally efficient and narratively coherent. The challenge lies in balancing the complexity and adaptability offered by GPT-4-inspired architectures with the need for predictable and designable NPC behaviors that serve the game's narrative and mechanical needs. This balance will likely require a hybrid approach, combining insights from advanced AI models with game-specific AI techniques. Looking ahead, the future of NPC cognitive architectures likely lies in the development of hybrid models that combine the insights gained from general AI advancements with innovations specific to game AI. These models could potentially offer the best of both worlds, the adaptability and processing power of advanced AI systems, and the narrative coherence and game-specific behaviors required for engaging NPCs. Advancements in real-time learning and adaptation for NPCs represent another crucial area for future development. Creating NPCs that can genuinely learn from their interactions with players and evolve over time could revolutionize game narratives and player experiences. As these technologies advance, we can anticipate more immersive and dynamic gaming experiences. NPCs could become more than just script-following entities, they could evolve into complex virtual beings that offer unique interactions for each player, enhancing replayability and deepening player engagement with game worlds. As we push the boundaries of NPC cognitive architectures, it's crucial to consider the ethical implications of these advancements. Issues of player privacy and data collection become increasingly relevant as NPCs become more adaptive and personalized. Game developers will need to carefully balance the desire for realistic and responsive NPCs with respect for player privacy and autonomy. There's also the challenge of balancing realism with player agency and overall game design. While highly intelligent and adaptive NPCs might seem desirable, they could potentially interfere with carefully crafted narratives or game balance if not implemented thoughtfully. Moreover, as NPCs become more sophisticated, there's a potential for misuse of this technology. Developers and ethicists will need to grapple with questions about the appropriate limits of NPC behavior and the potential psychological impacts of interactions with highly realistic virtual characters. The insights gained from GPT-4's architecture offer exciting possibilities for the evolution of NPC cognitive design. The mixture of experts model provides valuable lessons in efficient information processing and dynamic task allocation that could enhance the responsiveness and adaptability of game NPCs. However, it's clear that direct application of GPT-4's architecture to NPCs is neither feasible nor desirable. The unique requirements of game environments, including real-time interaction, narrative coherence, and the need for designable behaviors, necessitate continued innovation in game-specific AI technologies. The future of AI-driven NPCs lies in finding the right balance between the processing power and adaptability inspired by models like GPT-4, and the specialized, game-centric capabilities required to create truly engaging virtual characters. As we continue to push the boundaries of what's possible in both general AI and game AI, we can look forward to increasingly immersive and interactive game worlds, populated by NPCs that offer deeper, more meaningful interactions with players. This journey of innovation promises not just more realistic games, but new forms of storytelling and player engagement that we are only beginning to imagine. The evolution of NPC cognitive architectures, informed by breakthroughs like GPT-4 but driven by the unique needs of interactive entertainment, stands poised to redefine our understanding of virtual worlds and the characters that inhabit them.